Okay, I guess we will get started. So welcome everyone to this month's meetup. Thanks for having me. My name is Charlie Koster. I am a software developer for a company called Avature in Omaha, Nebraska. And today we're going to take a deeper dive into Elm. So before I get super deep into Elm, I want to kind of build the context about what Elm is. And Elm is a functional language for building web applications. So if you're doing web development, you're probably familiar with this tech stack: React, Redux, TypeScript, some immutability solution, some functional JavaScript solution like Ramda or Lodash. And Elm is really the replacement for all of those. So Elm has virtual DOM, it has a unidirectional architecture, it's statically typed, everything is immutable, and it's a functional programming language. So you could do, for example, partial function application, function composition, and those sorts of things. So that is, from a 10,000 foot view, that is what Elm is. If you go to Elm's website, this is what you see. It says Elm is a delightful language for reliable web apps, and it happens to have great performance and no runtime exceptions. So yeah, so that's from a 10,000 foot view, that is Elm, and we're going to start diving a little bit deeper into it. But if you were to, before we go into it, if you were to ask me what are my favorite parts about Elm, it's these two things. That's the subtitle of this talk. It's the simplicity and its concepts and its syntax, and also the fact that you can get enforced invariants. And this is not something that you can get very easily with just plain JavaScript or even typed solutions like Flow or TypeScript. So for the rest of this talk, it's going to be relatively informal code walkthroughs. I acknowledge that maybe some people have seen Elm before. People watching this video or listening to this meetup, some people have seen Elm before, some people haven't. The examples I'm going to show, I'm going to sprint through the syntax relatively quickly. If I go so fast that you don't really recognize the syntax, that's okay. I guess more pay attention to the concepts that I'm teaching, and we can ask questions about the syntax later on. So let's dive into this. We want to go to Chrome. Okay, so I'm going to show maybe 3 or 4 examples here, and I'm just going to build up in complexity, and we'll show just what Elm really is. So first we're going to do maybe 5 minutes on the basics. I'm not going to teach you the entire language in 5 minutes, but I want to, again, just kind of reiterate some concepts. So in Elm is a functional programming language for the web, and it's part of the ML family of languages, so it's not part of the C-style family of languages. You don't see a lot of C-like syntax. So here's a real, just simple example. How do you get Elm going? You have a main function, and that main function returns text, and this compiles in the browser, and you see hello world on the right. So Elm is just very simple HTML in the browser, and there you have it. Elm is also has records, and just based on all the types that you would expect. So here I'm creating a record that has an integer and a float and a string and so on. If you're coming from a JavaScript perspective, having this kind of formatted this way feels kind of foreign with like the leading comma. It's actually something you get used to relatively quickly, and the Elm community has a sort of standardized formatter. So basically all of the Elm code that you will see will be formatted in this way. And in fact, this web program, has the formatter built into it. So if I click format, it'll actually automatically reformat the program. So it has records. It also has aliases for records. So if I want to define a person, I hope the screen share is not lagging too much, but if I wanted to create an alias for a person where the person has a first name, a last name, and a favorite color, I could do so by creating my own type or my own type alias and naming it and specifying the types of the underlying values. And then I could say, well, I'm going to create 2 people. Person 1 is going to be annotated as a type of person, and you see its implementation below. The same thing for person 2. So this is one area where Elm parts ways from languages like TypeScript and Flow. With languages like TypeScript and Flow, you see the annotations inline. So you might see something like this in TypeScript. You'd see var person1 is of type person, so I can't type, and you equals, and then you see all of that. This is actually, that kind of inline annotation isn't so bad when it's just a single variable, but when you get into functions that have multiple arguments, that gets kind of hard to read. So Elm favors the put the annotation on a separate line. Going down a little bit deeper here, so we can have we have lists, we have functions. So let's talk about what functions look like. Let me reformat this. Uh-oh, I gotta fix that. 1 second. Okay, so you have a list of people. So here's a list of 2 people, person 1 and person 2. Functions in Elm look something like this. So in the annotations for a function, you specify multiple arguments separated by an arrow, and all the arguments leading up to the last arrow are the function arguments, and everything after the last arrow is the actual return value. So this is a function called person_info, and it's defined such that it takes a person as input and it returns a string. And actually, if we call this real quick with something that we care about, so let's go up here. We're going to call person_info with person1 and compile this. And you see that this should compile, and it's going to print out the string that we wanted to print out. First name with the last name, the favorite color is the favorite color. So that is just us invoking a function. Elm is like I said before, a functional language. So it has partial application and function currying. So if I wanted to go through all of the people, let's say there's in this people list, I want to go through each one of these people and print out this string for each one of those people. How might we do that? Well, one thing I might do is, let me mock up something real quick where I'm going to just print out an unordered list of text. So just to get the basic bare bones going here, this is going to create some HTML where I forgot to specify something here, where every list item is of type text. So we'll compile this. Okay, so we have one list item. Quick digression here. In Elm, the HTML, the virtual DOM, these are really just functions where each function has 2 arguments. The first argument are the attributes to that HTML element. The second argument are the children. So that's how that looks like. Now, if I wanted to create an unordered list of all the people names, what I could do is do list.map and provide some function here. So let's say I want to call this, I don't know, .first, and provide it people. Uh-oh, I got an error, and this says, so this is expecting a function that takes in a person and returns a list element where it's going to be person.first. So I'm going a little bit quickly here, but let me explain what's going on here. In Elm, everything is immutable, everything's a record. And so even though people is a list, there is no .map that you hang off of people. If I wanted to map over this collection of people, what I want to do is call list.map. List.map takes 2 arguments. The first argument is a function. So this is an anonymous function or a lambda expression. And the second argument is the actual collection. And what this says is for each person in that collection, I'm going to return a new list item, some new virtual DOM, where the text for that list item is going to be the first name of that person. And so when we run this, this is exactly what you see, is John, Jane, those are the names of the people. To look at some of the, another thing to show here is this is what's called a pipe operator. And the way you can read this is, look at this as like an arrow, and this is the direction the data is flowing. I could use the pipe operator in the opposite direction if I wanted to, and that would look something just like this, and this should behave exactly the same. Recompile it and you get the same output. So this is just piping data from one expression into another expression, the unordered list expression. And then the last example I wanted to show here, because I don't want to delve too much into the syntax, actually I'll show two more things. One is union types. So in Elm, you can have something called a union type, and a union type is essentially an enumeration of values. So here I create a type color. So it's just a custom type, and it could be one of three different values. It could be blue, red, or green. So if I wanted to use this, I can actually specify this union type as part of my person alias. So instead of favorite color being a string, I'm going to basically say favorite color is going to be of type color. Now, if we compile this, this is actually not going to work because the compiler is going to say we're using color in some cases, but some of our functions are expecting a string specifically. So what I do is I created a helper method down here that converts a color to an actual string here. So I define a function that says for a given color, return the corresponding string. So for a given color variable, this is what's called pattern matching. So this basically says pop open that union type, and if that color was blue, returns the string blue, the quoted blue. If the color was red, return red. If the color was green, return green. And then we could use this inside of a function here. So if we go through, actually this still won't work because I have to update person 1 and person 2. So let's update that quick. Blue and green. I should compile. No, line 62. Yes, because we did not call color to string there. Okay, so now that the program compiles, and now if we wanted to print this out, what we could do is say text person info for each person, compile that, and we should expect to see John Doe's favorite color is blue, Jane Doe's favorite color is green. So we actually have that working. I don't know what just happened to the screen. There it goes. Okay, so that's the basics of Elm. You have first class functions, higher order functions, everything's immutable. Again, if you haven't seen Elm before and the syntax still doesn't look too familiar, don't worry about it. Because this is, I'm happy to answer questions later on. Again, I just want you to pay attention to some of the concepts that we're explaining. But the important thing I want to show here is from a simplicity perspective, in order to do a lot of the same things that you're seeing here in just a plain JavaScript web application would require much heavier syntax to combine, for example, Lambda and TypeScript and Immutable.js. A lot of this would be a lot more clunkier and verbose, whereas with Elm, it's a very functional language. So yeah, I think you guys get the point there. The second thing I want to show before I show an advanced example is the fact that Elm is unidirectional. So on the right side here, this is a simple Elm program that you can get to from the Elmling website. There's just two buttons, and these buttons will allow you to increment and decrement a number. So here, our main looks a little bit different. Most Elm programs will not just be a static page. This main basically says this is going to return a static page and there will be no reactivity. That's one option. Another option is to specify that your main program will have reactivity and that there will be a specific model and message going on. So message is Elm's convention for the equivalent of a Redux action. But it just by convention refers it to as message. And the way this works is with a basic program, you're going to give it a record, where you give it an initial model, a view function, and an update function. So this is going to be a unidirectional architecture that's somewhat similar to Redux. So to dive into this, what I do is I create an alias for the model. The application's model is just a simple integer because that's all that's really required to maintain the statefulness of this simple view. I define a constant where the initial model is set to 0, and then I have a view function. Out of the box, these functions aren't actually annotated, and I like annotating these because it's helpful for me, and it actually helps the compiler out. So this view function is actually a function that takes in a model and returns basically virtual DOM. So for a given model, you see that div and the 2 buttons that you see on the right there. Again, the messages are really the actions. So there are 2 actions. There's a decrement action and an increment action. And then lastly, we have the update function. And the update function says, for a given message and for a given model, let's return a new model. And that new model will be sent to the view function and re-rendered. So if we compile this, this should hopefully still behave okay. I have to include something in the import up here. Okay, now everything's happy again. So to really test the understanding of how this unidirectional architecture works, a good example of how to test this is to try and add a new button. So let's say we wanted to add a reset button. I want to be able to arbitrarily increment and decrement a number and then click reset and have it reset to 0. So let's go through this and see what it looks like. I'm just going to copy paste this and say I want a new button where the text is reset, and when that button is clicked, I want it to dispatch a reset action. This isn't going to work right away, but the compiler is going to guide us and help us fix this program now. So it says it cannot find variable reset. Okay, that's because it's dispatching a message, but reset is not defined in this union type, so I will define it there. We'll compile this. This is still not going to work because what the compiler is basically saying is in this update function, when we do pattern matching on the current message, we are only handling 2 of the branches, and the 3rd branch is not being handled. In just regular JavaScript, this would be kind of a default to returning undefined, but in Elm, there is no undefined, so we have to actually handle all these cases here so that there's always a successful return value. So when there's a reset action, I need to return a new model, and because my model is basically just an integer, I can just return 0 right here. We compile this. Now we see everything is type safe, everything is compiling okay, and if we click plus and minus and then reset, it goes back to 0. Click minus a few times, click reset, it goes back to 0. So this is a unidirectional architecture because we start with an initial model, we render the view with that model. When the user interacts with the view, it dispatches an action. That action is handled by update, which returns a new model, which then gets re-rendered. And so that's the unidirectionality of the program. So those are the 2 basic examples. Again, to do this sort of thing in Redux requires quite a bit more boilerplate, and honestly, it's just not as clean. You might be looking at this and think that this is hard to read. Again, Elm syntax is just a little bit different. Once you look at it and write a couple programs for a couple hours, it really becomes not that hard to read. So I actually like kind of the simplicity of even just the unidirectionality of how Elm's architecture works. Okay, so those were the 2 simple examples. Now I have 2 more, a little bit more in the weeds examples. Again, syntax maybe not as familiar, but I want to just kind of focus on the concepts here. So this example I'm going to do isn't terribly complicated. This is I want to basically kind of recreate a GitHub view here. If you go to any repository on GitHub, sorry, I'm just collapsing some tabs here. If you go to any repository on GitHub, you can actually go find the labels, and these are the labels you'll see on the issues for that repository. And all I want to do is recreate a simple view here. And I actually have quite a bit of this already done. So if I search for any repository, like the one we were just looking at, and do search, you will see that this prints out all of the labels for that repository. Now, this example isn't, crazy impressive, but it's small enough that we can kind of wrap our heads around it in 5 minutes. But also, it'll help demonstrate a lot of common problems that you see in JavaScript applications today, and how Elm helps solve those problems. So, first thing I want to show is, let me refresh the page here. So again, this is elmling/elm compiler. I hit search. I don't know if you saw it because the screen share might be going too quickly, but there's a please wait that occurs while it's going and fetching the data, and then it goes and shows the actual labels. And to show some of the code behind this, there's a few hundred lines in this file, so I'm not going to show everything, but I'm going to show some of the important pieces. So the Elm file to create this view looks like this. First, I'm going to go over some of the types. So the model for the entire view looks something like this. The way I've modeled it, when reading this, don't take this as how you should model your app, because this is kind of a before and after. This is modeled in such a way that you'd see in sort of JavaScript applications, where you see kind of a root level object with a nested type. So this is the string for the input. And then you have some label data. So this is another nested type, where this nested type looks something like this. So whenever we are retrieving our labels, we have a Boolean set to true. If there's an error, then we're going to have an error right here. And if there's results, those results go right here. We also have 4 actions, 4 messages defined for this view. So as the user is typing in input, we need to update the model. We need to update the repository string. And then when the user clicks search, we need to first go retrieve the labels. And then those labels can either come back successfully with a list of labels, or they could fail to come back. So these are the basic types that we're going to be working with. To look at the view part, I'm going to skip some of those views, and I'm going to focus on just the results view. The results view is going to be just this part that I've highlighted. It's just the actual labels under the search form. So this results view is a function that says, for a given set of labeled data, I'm going to return some virtual DOM. So this might look somewhat familiar, and if you're a JavaScript developer, we say if the users click the search button, so if we are retrieving data, then we want to return some virtual DOM that says, please wait. Otherwise, we say, if there is not an error, which is what that means, then what we want to do is pop open our maybe type and display, sorry, this says if there is an error. I said that backwards. If there is an error, then we basically want to pattern match on that error, pull the error out of the maybe type, and return that as virtual DOM. Notice that this expression just basically does nothing because when there is an error, it's actually impossible for this case to hit. And you'll see this as a code smell, as this shouldn't happen. Whenever this is basically, when you see this in a code review, basically asking for a comment, but this is the sort of thing you might see in a JavaScript application. If we are not retrieving and we don't have an error, then it's safe to assume that we do have some results. And here you see on the last else branch, we have an unordered list of result list items. So we basically say we feed, we go through all the results and map all of those to list items, and we style those appropriately. So that's what you saw in the view right here. That view function produces this virtual DOM. And then one more function I want to show is the update function, and then I want to explain some of the bugs with this. So here's an update function. Again, it says for a given message, for a given model, I'm going to return a new model. In the previous example we looked at, this annotation looks slightly differently. This basically says we want to do a particular type of Elm program that could perform side effects. And in this case, we want to be able to do an HTTP request. So the annotation changes slightly, but all this is saying is for a given message and model, what's the new model and what side effects do we want to produce? So we do a pattern match on the message, and we enumerate over all 4 of the different types of messages. If the user is typing in into the input field, all we're going to do is update the user input part of the model. So that's all that's going on right there. If the user clicked the retrieve button, then the retrieve action will be dispatched. And all we want to do here is call a helper function that sets the retrieving value to true, and we want to do some side effect. We want to actually do an HTTP request to go and fetch those repositories. Now, Elm will handle performing that side effect, and when that side effect resolves, it'll either resolve successfully or it'll be a failure. If it was a failure, it'll dispatch this action and give us some error. So when there's an error, we want to set retrieving to false and set the error. Otherwise, if it was successful, again, set the retrieving flag to false and set the results. Now, I went through that kind of quickly, but there are, I think there's 3 bugs with how this is currently implemented. And this is actually something that's, the bugs that I'm going to show you are something that you see actually pretty frequently, and they're just very common. So let me go over these. So let's say I mistype my repository here and I click search. What's going to happen here is it's going to say there's a problem retrieving the GitHub repository information. Okay, that's expected. Now what happens if I correct this information and click search again? I don't know if you saw it, but there was a please wait, but now I still see the same view here. And if we look at the network request, I click search, it actually comes back successfully. Here's my bug label, here's my canonicalization label, meta, and so on. And what's actually happening here is when there's an error, we set the retrieving flag to false and we set the error. But when there's a success, we don't reset the error. We don't blow the error away. So in the view function, what ends up happening is there is still some error. And because we check for the error first, we're always going to return some text if we find an error before getting a successful result. So that's one bug that you may not find in development. Hopefully you find during QA. Hopefully you find it certainly before production. Another issue, so 2 more issues here. If we search for this repository that I posted this code to, do a search. Actually, I've got to refresh the page, so I blow away the model. Okay, so I do a search for this. Okay, again, here's another problem. I do a search. This is a repository where I've deleted all of the labels. And this is can be classified as sort of a UX bug. This is the bug where a response has come back successfully, but it came back with empty data, with no data, which is actually valid for this particular example. However, from a user experience perspective, we aren't telling the user that there is nothing there. So that's another problem. And then the last problem here is when I refresh the page, you'll notice that there is nothing telling the user what to actually do. The user doesn't know that they need to type into this box a GitHub account followed by / followed by a GitHub repository. So that's another user experience bug. That is not. I think of it as another user experience invariant that's not being upheld. So Elm actually allows us to bring the idea of invariance into our web applications and really obtain these desired invariants. And one way that we can do this is something called, again, with a union type. This is going to be an example based off of Chris Jenkins's work. He has a blog post and a video that elaborates over this example. But basically what I want to do is I want to create a new union type. And this union type is going to represent the valid states of the program. As you notice with this program is capable of representing many invalid states, which when you kind of sit back and think about it, does it really make sense that we model our solution in a way that it can represent bugs? Well, when you phrase it like that, no. Maybe we should try and model our solution so that it's incapable of representing bugs. So how would we do that? Well, there were 5 states that I went over. There was the state where the page initially loaded. So that's one state. Another state is we clicked the retrieve button. Another state is the response came back successfully. Another one is there was a failure. And then lastly, there was a state where the response came back successfully, but it actually came back with nothing. So I'm going to call that the 0 state because that's what if you talk to someone on a design team, they refer to it as a 0 state, and I think that's a pretty good terminology for it. Now, what we ultimately want to do is have this represent all of our label data, but we need to include some kind of payload. So when there's a success, there's actually some kind of payload with that, which we're just going to call A. And when there's a failure, there's some kind of failure message. So we're just going to call that B. So in other words, what you can do is you can parameterize your union types such that they can contain payloads. Okay, so now we have a new type that we want to start using, and it completely whitelists all of the valid states that we want to represent, and it contains much fewer invalid states. So we basically want to replace all of this with that new type. So label data is going to be an alias for remote data. Remote data is parameterized, so we need to specify an A, which is the success, and a B, which is the payload for the failure. So the A is going to be the list of strings, because that's going to be our results. The B is going to be a string, and we can delete all of this. And now we save, and we're going to let the compiler guide us. I don't know if you can see it on the right side there, but there's a red mark that indicates this is where the next issue is. So this is our initialization function that basically says when the app first loads up, what's your initial model and what are the initial side effects you want to do? Are there any initial HTTP requests you want to kick off? I'm actually going to simplify a lot of this because the way I've modeled the data allows me to simplify it pretty greatly. So what I'm going to do is I'm going to say we're going to create a model. The model takes 2 arguments. The first is the user input, the second is the label data. So the initial user input, we're not going to touch for right now, but we do need to specify something right here. Again, this second argument to the model is going to be our initial label data. So we need to specify one of these 5 values, and because we're in the init function, only one of these actually makes sense right here. So we're going to assign initial and place it right here. Again, I know this is going pretty quickly, so if you have questions, I can encourage you to write them down, and we can go over them later. But all this is basically saying is, this is my initial model. I have an empty text box, and my label data is initial, and we don't have any side effects when we first load up the app. So I've saved. Now I need to fix the next error. Again, I'm going to comment this out. So instead of doing this if, else check, what I instead want to do is we have this label data that is now of type, is now a remote data. It is a union type. So I can actually pattern match on this. So there's an initial, there's a retrieving, a success with results, a failure with an error, and a 0 state. So here, if we just plug these in, this is the retrieving state. This one was the error state. And this one was the success state with the results that we pulled out of the pattern matching. Now, if we look at that, we've actually pulled out everything that we wanted to pull out, and this reveals that we are missing 2 whole branches. So this reveals the 2 bugs that we just discovered later on outside of development. So we are missing the initial state and the 0 state. Okay, so let's handle that quick. The initial state will say, please enter a GitHub repo in the format of, let's do slash quote, account names slash repo name. And then the 0 state will say, there are no labels for this repository. I save, it auto formats, and there we go. And then I've got to fix our update function. This one I'm just gonna kind of whiz through. I've got 3 helper functions down here. Just gonna cut to the chase and say we don't need any of those, which is kind of nice. Instead, what I wanna do is update these 3 branches. If we are retrieving, what we wanna do is update our model. We wanna update the label data part of our model and set it equal to, again, this is going to be one of those 5 values in the remote data type. So if someone has clicked the search button, we want this to be retrieving. Save that. That one's good now. If there was an error, what we want to do is update the label data to say failure error. And lastly, if it was successful, we want to say update the model and set the label data to be success results. We're not quite done yet because we haven't taken care of the 0 state. So I'm going to create sorry, I don't want a let expression. I want an if expression. I want to say if list.length of the results is greater than 0, then do this. Otherwise, we want to be in our 0 state. And this should actually be all that's required to make the compiler happy. List.length of results is greater than 0. On the right side, the compiler does look happy. And if we rerun this, refresh the page, okay, let's see how many bugs we knocked out. On initial page load, it says please enter a GitHub repo in the format of account name and repo name. So if I fudge this, I click search, I saw a please wait. I don't know if you saw it on the screen share, but it did say please wait, and we see an error. Okay, so we're going to have an error before we have a successful result. So let's see how this looks. So we do elmlang/elmcompiler and do search. Okay, so even though we had an error beforehand and a success later on, we are now seeing the correct result because the model for this application is not capable of representing that bug anymore. And then if we go get a repository that doesn't have any labels, do a search. Example, I spelled it wrong. There are no labels for this repository. So again, we just fixed 3 bugs, and in doing so, we eliminated a handful of lines of code, and all it really took was creating a new type that better resembled the invariants we want to uphold. With our certain invariants with regard to asynchronous data, and those invariants are basically, we want to handle from a user experience perspective, we want to handle these 5 states. The old model could handle those 5 states, but they could also represent a lot of bugs. Now we have a model that is not capable of representing those bugs anymore. So that is one example of how to do invariants. I have one more example using this same labels application to show another example of invariants, and then I'll open it up for questions. So looking back at this example, let me put a working example back up here. So let's say we're talking to our designers and we recognize that this is a list of labels. This is a list of strings. Let's say for whatever reason, I know this is kind of contrived, but for whatever reason, whenever we show a list of strings in the app, we want to show them in descending order. We want them to be reverse alphabetized. And in talking with our designers, we're kind of fairly confident that this isn't the first time, this isn't the only time that we're going to want to show a reversed set of labels inside the application. So again, it's kind of contrived, but it's small enough to help demonstrate the point. So what we decided to do is to create a separate module in Elm that basically represents a type that's going to represent some labels and the direction that they're sorted. This will allow us to kind of reuse more code across the application, and yeah, just help with maintainability. So again, this is kind of the before and after example. So don't stare at this too hard, but basically what I've done is I've created a separate module called sorted labels. I exposed a new type called sorted labels, where this is an alias for a record that has a list of strings for the labels and a sort direction, which is either going to be ascending or descending. Now, if you look at the documentation for this, this is a type for a sorted list of strings, as I just said, but I also list an invariant that I want to uphold for this particular module. I want this list to always be sorted in whatever direction that was specified. Okay, so that seems fair. The naive way to kind of enforce this is to expose a function that says, if you give me that record, I will return you a sorted list. So the implementation is kind of how you would expect. We say, let's look at the direction that the given sorted labels is specified, and if it's ascending, then sort it one way. If it's descending, then sort it and reverse it, so it actually becomes descending. And there we have it. We have a sort of naively implemented sorted labels. Let's go implement this or go use it, and this will just take just a minute. So if we have our sorted labels, I want to basically use this in place of any list string that you see. So the A on the remote data will now be sorted labels, and when the response comes back successfully, it'll now be sorted labels. Save the file, and the compiler tells us we got a few things to look at. Okay, no big deal. This error says the second argument to map is expecting a list string, but we're giving it a sorted labels. So we need some way of converting results, which is sorted of type sorted labels, into a string. We know how to do that. There's an as-list function that is exposed. We save that, and now that's happy. One more error down here. I know this isn't code that you haven't seen before, but basically it's the same sort of thing. I'm basically taking a JSON response and turning it into Elm types. So this is saying we want something to be a sorted labels, but it's actually a string. It's okay, we know how to do that. All I need to do is say this is a sorted labels result, and according to our designers, we want everything to be descending. Let me show ascending real quick to begin with before I show the descending part. So I don't see any more errors. Actually, I do. This needs to be as list as well. Okay, so with just a few keystrokes, we were able to update the file to now represent, or to use our new data structure. I refresh the page, and we look at compiler. Okay, we see this is in sorted order, but our designers said that this should be in descending order. Okay, so let's look at where we specified that. Down here we said it was in ascending order, and I want this to be in descending order. Okay, so I click save. We might expect this to work, but this is actually not going to work, and I'll explain why in a minute. That did work. Oh, I know why it did work. Okay, so this is working because we are using the as-list function to sort that list. So these labels are now in descending order, as you can see right there. But something that might happen in a code base as it ages and as several different developers look at it is you may have someone does some basic refactoring, and they see something like this, and they see that, okay, I see that as list is just turning results into a list, but we could actually clean this up to not use the pipe operator and just say results.labels, because that's a transparent type. And if they were testing this with the ascending list, that would work just fine because the results by default come back in ascending order. But if they were testing this in the descending order, they would notice that there's a bug here. So if I refresh the page and do elmlang/elm compiler again, okay, this is a bug. Here I specified that I wanted my sorted labels, that sort direction should have been descending, but we're looking at it and it's in ascending order. And the reason for that is because in the code here, this sorted results is a sorted labels type, and that type is completely transparent. I can dive into this and just access the string, and if that string is in ascending order, like it is by default when you do this actual request, then there's nothing honoring the sort direction here. So this invariant is not actually being upheld. So in the previous example, we saw how union types can help us get invariants. And we can do the same sort of thing here again with a union type. It's a special kind of union type called an opaque type. So let's re-implement this file with an opaque type. Instead of creating an alias for a record, what I'm instead going to do is I'm going to say I'm creating a new type, sorted labels. This is going to be a union type with only one value. That value is going to be called sorted labels again. Again, there's no problem with naming it the same thing as the type. Elm knows how to handle that. There's going to be a list of strings for one payload and a sort direction for the other part of its payload. So now we no longer need this. We need this alias for a record. Okay, so the intent here is to create a union type, but to make it opaque. And what I mean by that is to not do this. If I expose sorted labels and I do this syntax where it's parentheses ... what that actually does is it exposes all of the values for that sorted labels type. And what it essentially does is it allows consumers of this module to create their own sorted labels from scratch. I actually don't want that. We don't want that to happen. So I'm going to make this an opaque type. I'm not going to expose those values. Instead, and I'm not even going to expose the sorted direction either. Instead, what I'm going to do is expose a function that allows someone to create a sorted labels. So I'm going to expose a function that says, if you give me a list of strings, I'm going to return to you a sorted labels. So we have ascending labels for a given labels. We are going to construct it for you. So this is going to be our labels. This is going to be ascending. And we can do the same thing for descending. Too many S's. Descending. And update that. Expose these from the module. And there we have it. We now have a way to force the user to, not force the user, we've now created an opaque type so that the user can only construct this type by using one of our constructor functions. Okay, now we still want to use this as list function. We basically still want to say, if you give me a sorted labels, I will give you a list of strings. But we need to update some of the syntax here because now we're not pattern matching on the direction. We're pattern matching on the sorted labels itself because sorted labels itself is a union type. So one of these branches is going to say sorted labels ascending. The other one is going to say sorted labels descending. Those are the two patterns that we could possibly have for the type that we have defined. And if it's one way, we're going to sort it, those labels. If it's the other way, we're going to sort the labels the other way. And now the program compiles. Okay, so now I want to actually use this in the program. So let's update this. Let's see what the compiler tells us. The compiler is telling me that this is no longer valid, which is correct. So the intent here is to construct a sorted labels type in descending order. Okay, we know how to do that. We're going to use the helper function that we created that takes in a list, which is the result. Okay, now that's happy. We have another error right here. So we're trying to map over a list, but this isn't a list. So what we need to do is called asList. AsList expects our actual sorted labels type, which is what we do right there. And is that everything? I think I've covered all the branches there, or all the errors. So I rerun this. There are no errors because the page loaded. We do elmlang/elm compiler. I do search. And we see that this is in descending order, which is as expected. If I instead wanted it, a designer changed their mind and they say, okay, we want it in ascending order now instead. So I change that to ascending labels. Refresh the page. Again, elmlang/elm compiler. Now it is in ascending order. So far the invariant is being upheld. Okay, what if we wanted to try and break this? Let's say let's do our best to try and break this. Let's have a descending labels. It's going to be equal to result piped into list.sort piped into list.reverse. So when the result comes back, it is by default sorted in ascending order. We sort it in ascending order just to be sure, and then we reverse it, and then we pass that to ascending labels. So let's see if we can try and break this. We'll run this and see if it actually breaks. Lang/elm compiler. Okay, it's still in ascending order, even though we are storing it in a descending order. And also, if we go back to our asList function up here, can we break it like we did before? Can we do results.labels? Well, no. It's an opaque type. It's not a record. There is no labels attribute. So we've now basically created a program where if you try and violate an invariant, the sorted labels invariant, that program will no longer compile. So if you want a compiling program, you need to adhere to the invariants and you need to follow the syntax that we've defined. And if you look at this, in order to get an invariant, there wasn't much there at all. We created a union type, we exposed two constructor functions to construct that type, and then the only way to pull out the labels is to use this function, which will sort it accordingly. Now we still want to write some tests for this to make sure that it's actually, behaving as we'd expect. But otherwise, that's basically it. So I'm hitting the 1 hour mark, so I will wrap things up here. So last thing, a couple of recommendations. The Elmlang guide is a good place to start if you want to look more into to Elmlang. A lot of the concepts that I'm talking about are around invariants and impossible states. This, in the Elm community at least, this originated in a talk by Richard Feldman about making impossible states impossible. That is a talk from the first Elm conference. Just go to YouTube and search for that title, Making Impossible States Impossible. It's only like a 20-minute talk, and it's a really great talk. There's Elmlang Slack. If you ever have questions, don't go to Reddit, don't go to the Google groups, go to Slack. Go to this Slack Heroku app, and someone will help you. It's very helpful. And then if you want to play around with some code, there's that first example I showed was called LE app. It's just an in-browser, basically IDE for Elm. And then you have the code that we showed today on my GitHub repository. I guess one more shameless plug is at Koster22. If you look me up on Medium, I blog about Elm quite a bit. But otherwise, that's all I had. Let me unmute everyone. And so everyone is unmuted. Cameron, I don't know if there's time for questions, but I can take some questions if anyone has any.
Yeah, Charlie, thanks so much for doing the presentation. It was awesome. And yeah, we got time for questions. So, let's open the floor up. Yeah, go ahead.
Hi, Charlie. My name is Mark. I was interested in your use of the term invariant, but I can't say that I exactly understood what you meant by that. Could you expand on the concept of an invariant in context of what you were speaking about?
Yeah, and in fairness, I'm not using invariant in technically the correct way. So the technically correct definition of an invariant is something that remains true before and after executing some function or some program. So for example, before and after running this function, this number will be positive, and it will never go negative. That's a kind of a contrived example. The way I'm using, what's that?
A loop is, then that's how you prove that a loop is correct. So are you talking about proving the correctness of something, or?
When I'm talking about invariant, I'm talking about some guarantee, some rule that I want to be true. So when I talk about user experience invariants, what I'm really talking about are basic user experience rules that we want to always adhere. So for example, whenever I'm retrieving data, I always want to handle, the case where we haven't fetched anything, or we have a success state or an error state or a zero state. So you could think of them as just rules that we want to always be adhered to, is the way I'm using that word.
Okay, thank you. Yeah, that makes sense to me. Yeah, thanks.
Yep. Any other questions? Okay, so
No, I think we're here.
Sounds like that's it then.
Yeah, so really quick, once again, Charlie, thanks so much for doing this presentation for us. I've seen Elm quite a bit, but I've learned a lot of new stuff. Also, Ellie, what a cool IDE, like browser-based. That was pretty slick.
Yeah, absolutely.
Just one more point of business. That actually wraps up FunctionalKnox for the year. So, Charlie, you're definitely letting us end on a high note, so definitely appreciate that. And next meetup will be first Tuesday in January. We'll have Mark presenting on Racket and language design in Racket. Correct, Mark?
Mm-hmm.
All right, yeah. So hope to see everybody there. And
Yeah.
Charlie, once again, thank you so much, man. Totally appreciate it.
Yeah, thank you for inviting me.